it. So I chose Game Maker because it did require you to learn. What in the world is that? I'll figure that out later. Where was I? I will do two things. One, I will take a look at how I initially built out my neural network, because what I'm doing is I'm trying to use the final version of it, which did take me quite some time to build, as my reference. And so I don't think that's a good idea. If you take a look, this was what it started off as, right? Like a very simple function in about 160 lines. And then I blew it up and I added so much more. And I got it to the point where, now it's a library with over 1,000 lines of code. I started off quite simple and then I built on top of that. So I think that's what I might end up doing with the RNN, just so at least we have something up and running, and then we can kind of, build on top of it, evolve it into a much more robust library. Another thing I just want to do is I just want to see how generally people use an RNN library, just so I can kind of start getting ideas as to how I want to go ahead and build mine. Oh, okay. This is kind of what I'm looking for. It looks quite similar to what we have, right? They have a linear, and then they have a sigmoid, which is kind of what we came up with, right? I thought about it a little bit, and so one thing I do want to do is I want to make sure that you can have the first set of weights in our neural network object. So you specify the first set of weights, or the parameters for the first set of weights, then you specify for the second set of weights the first activation, and then I have it such that you can continue building on top of that, and then you eventually have your final weights, and then you have your final activation. So it looks similar. Why don't I take a look at PyTorch and see how people usually implement an RNN. Okay, so these are the variables that are used in real life, so I'm just going to use them. One thing that I learned from just kind of going through the PyTorch documentation for their RNN is I was actually wrong. We don't need to account for this because this doesn't happen. Yeah, RNNs are just one layered, and then if you want to have a deep RNN, what you do is that you stack another RNN network on top of the original ones. Actually, in this case, it makes coding a lot easier. Damn, I've been trying to overcomplicate things. Okay, so now that we have a game plan, now that I kind of know a little bit more of what we're doing, let's actually start getting into code. Okay, so we've implemented our inputs, we have placeholders for our weights, and then we have our output. Now I just need to figure out how to get both activation functions into our network. One thing I need to decide though is whether or not I will use so for vanilla neural networks, there's kind of like an array that they use, and you just add different layers and different activation functions and different things to that array. I'm just trying to figure out whether or not I want to do the same thing for my recurrent neural network. The only thing that confuses me is that there are two different types of, so there's a non-linearity that you use within the hidden layer, and then there's another non-linearity that you use for the output. Is that not implemented in the library? Because the way I want to create it is I want to use a very similar method which I used for my normal neural network, which was to just dump everything into an array. So all the configurations into just an array, all the weights connecting the input to the hidden as one set, all the weights connecting the hidden to itself as another set, and then the activation for that, and then I'll have weights 3, so the weights connecting the hidden to the output, and then the final activation. That's kind of how I want to create it, and that's kind of what makes sense to me. Okay, you know what, forget it. I'm just going to go ahead and create it my way. That's that for now. Let me just test it out just to make sure everything's working as I expect it to. Up here, this is printing out a 1, 2, 3, 4 by 1, 2, 3 matrix. It's just printing it out in the dumbest way. So now all I need to do is I need to start implementing forward pass. Let's go ahead. Let me repurpose this and turn it into a feed forward for the recurrent neural network. I maintain it probably would have been so much easier if I just pressed ahead with my idea of a very simplistic, at least model, just to get things up and running. I think I'm overcomplicating things by trying to make it perfect from the very get-go. Oh, that's gonna be a challenge because I have different time steps. Okay, I need to draw this out. I tried a method whereby I wanted to repurpose the vanilla neural network library that I had and just kind of repurpose it and use it to create my recurrent neural network. I ran into some issues with that. The issue is mainly just that, there's a lot going on for the recurrent, or just to simulate that recurrent and that hidden that recurrent part of the neural network. And so rather than trying to like be all really fancy with how I implement the actual architecture of the network. So I have an array where I store the weights, and I have an array where I store the activation and this set of weights, and then that activation, yada yada yada. And then I try to loop through that whole array in a very complicated way, which again works really well when you're doing a vanilla neural network. But for the recurrent neural network, I really instead should be focusing on this type of an array, this type of a for loop instead. So that's what I'm going to do tomorrow. This ended in failure, but we'll try again tomorrow, and we'll see where that goes. I think my laundry is going to ruin all of my audio for tomorrow's vlog. Oh well, what in the world is a mufuru? Oh man, there's so much to learn. And so we're gonna skip this part as well. Hurts my eyes. You know, the next set of weights, the next activation, next set of weights, next activation. Let's wait for that thing to finish.